Hi, so this is number two in the homework, and let's see. So if I take a half circle and I revolve it around like a line, like the x-axis, you're going to get kind of like a ball, right? Okay, and then we're going to drill a hole into it. We're going to create like a bead. And when you drill a hole into it, you're going to notice that part of it, right? Part of it that we cut off, that rounded part also gets cut off. Okay, so we're not going to the end of the circle anymore because it was cut off as we drill a hole into it. Okay, and it makes it hollow. That makes sense? And it's going to make this part. Now, this part right here this part is hollowed out, but we're thinking more like a can, like a cylinder coming in. Okay, so and that's going to be on both sides of that shape when I drill through it. Um, so let's see if I can get back to this thing. Okay, so let's actually try this now. So this part right here, if I shaded this whole thing in, right, this part right here, including this part, would make a solid sphere. But because of the hole that I drilled through it, this part, okay, this part right here is empty. So to do this, when I rotate this around, what you're going to notice is, I'll try to use two different colors. So let me try to use red. Red will be, if I rotate the shape around, it'll be something like this guy. It'll be like a small, this circle will represent the hole. This right here, the blue one, represents the the part of the bead that's still there. Okay, the part of the sphere that's still there. So you guys will see that it's kind of like a big circle minus a little circle. Okay, so in order to do this, our formula, because this has a hole in it, we are going to use the washer method, if you guys recall, because there's an empty part right here. So the washer method is going to be the integral, okay, from some x to some x, because we're doing these circles along the x-axis. They're all perpendicular to the x-axis. This will be something like pi big R squared dx minus same x value, pi little r squared dx. Okay, so at this point, that's kind of what the washer is. Because the washer has a radius, the hole is a radius of 3, that's why over here, you're going to notice that this edge right here, everything that's less than 3 is gone. Okay, so that's why over here, when we do that, it actually has a kind of like a y value. 1, 2, 3, 4. 1, 2, 3. Okay? So that's where this will be. In terms of the big radius, okay, so the big radius is from here to here, okay? If you guys remember, big R is the function, kind of like the outer function minus the axis of rotation. Okay, because the outer function, this part right here, this guy right here, that's part of a circle. So it has to be the equation of a circle. The equation of the circle will be, if you guys recall, x squared plus y squared equals r squared. In this particular case, the r is 5 squared. Pretty much, if you get y by itself, this will be y equals plus or minus square root 25 minus x squared. Okay, so the outer function will be y equals square root 25 minus x squared. We're using the positive version because that's the top one. Now the axis of rotation is y equals 0 because it's the x-axis. Okay, now for the other part, little r is going to be, the reason why it's only 3, it's because this function right here, this is just the straight line. This is the line y equals 3. So it's still kind of like the inner function if you want, the smaller one, minus the axis of rotation. Oops, if I could spell. Okay, rotation. And pretty much the inner function will be y equals 3, and then axis of rotation is still the same one, y equals 0. So that's why it's just 3. That's why I only use the radius, because this straight line, this function, is 3. Notice I used slightly different kind of wording than top function minus bottom function. You can do that as well, but because this one has the axis of rotation, I usually try to do outer function, the one further away from the axis of rotation, and then the inner function, the function that's closer to my axis of rotation. So this guy right here is little r, and then from the axis of rotation to the edge of that circle, that's capital R, this guy right here. Okay, so putting it all together, we can kind of see from this one will be 1, 2, 3, 4. Okay, from 4 to negative 4. All right, so how did I know that? You can also just use this equation right here. You can put, the y value is 3, so if you put 3 in here, you get 3 squared, which is 9. 25 minus 9 is 16, and so the square root of 16 is 4. Okay, so my final will be from negative 4 to 4, and it'll be pi. It'll be pi, let's see, and we're just going to put inner function minus the outer function squared. So this will be the square root of 25 minus x squared minus 0. Okay, so the square root of 25 minus x squared minus 0, parentheses squared, because this right here, this whole thing right here is capital R. Okay, now we need to give the this little circle a little bit of thickness. So in the x direction, so this will be dx, and now we have an integral that we can do. Minus, okay, this little small circle area, so same thing from negative 4 to 4, pi little r squared. And this will be just 3 minus 0. No variables, nothing like that, just because this was a straight line parallel to the axis of rotation. So this will be squared, give it a little bit of thickness, dx, and then we are good to go. Okay, now you can actually put all of this together into one integral. Okay, this is little r. You can put it all together in one integral if you want. So for example, I think, let me see if I can get this, hopefully this will work. So you would type in, you would do this by hand. I showed the work in the answer sheet, so that's why I'm not doing that here. But let's see if I can get this down. Fn int. So you would go from negative 4 to 4, and then you could do the following. You could do, where's pi? So tiny, the screen. Second, pi. And then here you would just put each of those parentheses things. So parentheses, square root, so second square root, 25 minus x squared, arrow, close parentheses. If you wanted to, you could do minus 0, then squared. Okay, so that's pi big R squared minus, and then you do, say again, pi little r squared. Now, you can factor out the pi if you wanted to, and sometimes they do that. But again, I'm just writing it as I have it on my paper, so it's easy to kind of like map it out. Obviously, I would simplify 3 minus 0 to 3, but you know, whatever. So it's all good. And then dx, okay? And then you hit enter. Please let this work. Okay. And let's see if this works out. Our answer in the homework page. So I'm doing this. Hopefully, let's do 256 pi divided by 3. Yep, and we get the same answer. Okay, so hopefully that answers your question. Yeah, just keep sending me them through the email, and I'll try to see what I can do to help you understand a little bit better. Okay, all right, talk to you later.